Okay, so the first type of decay I want to cover is called alpha decay. So let's imagine a nucleus is very, very large. So alpha decay happens to nuclei that are too large. What am I talking about here? Well, first of all, let's think about what holds a nucleus together. There are two forces inside a nucleus. One of them is the force between the protons. So protons, they all have a positive charge, and they repel each other. So if I took a proton, if I had two protons, and I just brought them close together, there would be a tendency for them to want to push each other apart. Now, there's another force that, which is also active. So this is called an electric force. There's another force which acts kind of like a hook between a proton and a neutron. Actually acts between two different protons or two different neutrons. And you can think about this thing as kind of like a hook that hooks onto the nearby particle. Okay? So you could say if protons or neutrons are close together, they stick. So you can think of them as being a little bit sticky. Okay? If they're close together, they stick. If they're far enough apart, they won't stick anymore, and they really don't have much of any interaction at all. So if they're close enough together, one of them you can imagine one of them sort of hooks onto the other one, or perhaps they just stick together like that. Okay? And this sort of stickiness that they have is called the strong force. Okay. Now, let me draw a picture of a really large nuclei. So I said the alpha decay happens to nuclei that are too large. What would happen if a nucleus was too large? Well, first of all, let's draw a really large nucleus. I'm going to draw a whole lot of protons. I'm going to make them small so I can fit a lot of them in here. And I'm going to draw a whole bunch of neutrons. I need a lot of neutrons to stick those protons together. If I don't have a lot of neutrons sitting around to hold the protons together, then the protons will push each other away. They're all positive charges and they like to repel each other. So the neutrons are sort of holding the protons together. And there's this sort of stickiness of the strong nuclear force, which is holding the thing together. The problem is, what if this thing deforms itself in such a way so the nucleus is not a perfect sphere? It kind of wobbles around. It's kind of like a big bag of jelly that sort of wiggles around in all different directions all the time. Well, if the nucleus is really large, then what can happen is you might get, just by random chance, a little place where some little bit of the nucleus seems to be sticking off to the side a little bit, sticking away from the rest of the nucleus just a little bit. Well, if this part here gets far enough away from most of the rest of the nucleus, then the repulsion these protons with the rest of the nucleus might cause it to fly away. And that's exactly what happens in alpha decay. So what can happen in alpha decay is you take this nucleus, this is what we call the parent nucleus again, and a little bit of it breaks off and goes flying away. And that little bit has 2 neutrons and 2 protons. As we know before, this is called helium-4 nucleus. It's also called an alpha particle. And it goes flying away from the nucleus. It goes speeding away pretty fast because it's positive charged and the rest of the nucleus is positive charged. And what you're left behind with is all the rest of the protons and neutrons that you started with here. They stay together in a nucleus. And this one is what we call, the daughter nucleus. Now, we can say another thing about this process by thinking about the neutrons and protons. The helium-4 has Z equal to 2 because there are 2 protons in it. It also has a mass number of 4. A is the mass number, so 1, 2, 3, 4. There are 4 particles in that one. So the daughter nucleus so the parent nucleus lost 2 protons and 2 neutrons. So what can you say about the daughter nucleus compared to the parent nucleus? Well, you can say that for the daughter nucleus, Z must have gone down by 2. So Z is 2 less than it was in the parent nucleus, and A must have been reduced by 4 because there are 4 total particles less in the daughter nucleus than the parent nucleus. Okay? So in alpha decay, Z goes down by 2 and A goes down by 4 because you have taken away 4 particles and 2 of them are protons.